Hello everyone, my name is Reagan Rohr and I am a junior here at KU studying biochemistry. And today I'll be telling you about the effect of vitamin B12 on glycogen phosphorylase activity. A little bit of background on glycogen phosphorylase. It is an enzyme that cleaves a glucose 1-phosphate from a glycogen chain, releasing a free glucose. You will see in this image right here, this is the reaction where the glucose 1-phosphate is cleaved from the glycogen chain. This glycogen phosphorylase enzyme has a few different conformations depending on the tissue type it is in, muscle, liver, or the brain. There is a little bit different binding site, a little bit different conformation, but they're pretty much all roundabout the same. They're a little bit different, but not too much. This free phosphate group here is what is measured in the inorganic phosphate curve. This phosphate curve is what we use to measure the activity of the phosphorylase enzyme in solution. So the concentration of phosphate released is how we measure how quickly or how slowly the reaction is happening. So that's why it is the y-axis for all three assays. AMP is an inhibitor, or at least it was known and found to be an inhibitor in the assay I conducted. As you increase the concentration of AMP, it decreases the concentration of free phosphate released. So the same is true for caffeine. As you increase the concentration of caffeine, it decreases the concentration of phosphate released from, or the concentration of phosphate that the phosphorylase enzyme is cleaving from the glycogen chain, because we are doing the reverse of this reaction here. So it is actually adding the glucose 1-phosphate to the chain and then releasing this phosphate group, which is the phosphate that we're measuring. Both of these were known to be inhibitors, but were also found to be inhibitors in the assays that I conducted. They are used in comparison to the vitamin B12 assay, which is the unknown. I chose vitamin B12 because it is marketed as an energy enhancer, and I wanted to see if that was true in regards to its activity on the glycogen phosphorylase. It was found to be an inhibitor. Doesn't necessarily increase or decrease the concentration of phosphate released. It decreases the rate, or how quickly it releases the phosphate. So if you'll see here, as you add more vitamin B12, it releases or it cleaves these phosphates from the glucose 1-phosphate slower. This is why there is a decrease in the Michaelis constant, but not really a decrease in the maximum reaction velocity, showing that it is a competitive inhibitor and does decrease phosphorylase activity. This, you'll see down here, this decrease in phosphorylase activity shows that it is an activator of energy in the cell, or at least it increases the energy in the cell by inhibiting the phosphorylase enzyme. Because the phosphorylase enzyme cannot inhibit the energy metabolism processes of the cell. It is being inhibited by the vitamin B12. So I do believe that it's true that it increases energy, and I have found that it is true. I just want to thank my lab partner, professor, and the lab coordinator, and thank you for listening to my presentation.